Hey, what's up? We're uh, we're gonna check and see all the different ways we can hook up our 16 gauge drive. It's made up of 4 coils. Right now, this is a series going all the way around in this direction. Wait a minute, no, it's going in this direction. Series circuit. We're also gonna give a generous air gap. It doesn't seem like it's enough, but all right, let's get a tack reading on the speed here. 1,000. We're going 1,000 RPMs right now. That's pretty cool. $10.50. Now I hooked this up with a maglev, but it's riding high on the shaft, so there's a give and take with that. I need a little bit of weight, move it down on the shaft. But I don't have weight that isn't magnetic. And I don't need magnet weight. Because the neodymiums are just chilling in there. 1,300. That's freaking awesome. We're at about 1.8 watts right now. Two watts. We'll call it 2 watts. $14.50. Holy hell yeah, man! That's picking up speed. Not only is it picking up speed, it's picking up speed increase. So it's like increasing faster in speed. Yeah. 1,600 coming up on. Hello, hello. How's it going, everybody? We're gonna do like, I guess it's gonna be like a speed test, and we're gonna hook up these 4 coils in different orders. Right now it's in a series circuit going counterclockwise. 1,700 RPMs. And I'm thinking that the speed is gonna end up being the same, it's just how fast we get to that level, what we're gonna measure it. We'll adjust the air gap as well. 1,800. 2,000 is where we're going to cut it. And you'll see why. Hello, hello. I gotta keep my eye on what I'm doing right now, though. Let's see here. Bye. All right. 1888, 1900. $19.50. And it's got a tremendously awesome spin time. This will spin for 10 minutes. But I know a way I can make it slow down faster. Move these in here like this. We're going to do one more test. So we're going to move the coils in close. I'm gonna have to leave it like that. No, that's pretty good right there. Alright. Now that copper is acting kind of like a brake, just being there. Now, be very bouncy, very buoyant. There's no, barely any friction on the pole. But because it's so high, if it goes to one side or the other, even a little bit, it's gonna, get a lot of vibration in the shaft. So I think this one's gonna get up to where it's going faster, but I don't think it's gonna go as fast because of that copper effect that I suggested earlier. Yeah, we're already up to 1,000, 1,100. It's not even at 1,200. 1163, 2, 5, 2. I think. See, the copper is slowing down the rotor as much as it's influencing the speed of the rotor. So here, let me back these out, and we'll see how much faster and how quickly it gets going faster. Start with 1. It's picking up slowly. Oh, it's going down. Maybe that's too far. Oh yeah, that sounds different. Let's check it out. There we go, 1,200. Can we get 1,200? 1,200, there we go. So like, I call it the fringe, that very edge of the magnetic field coming off of the electromagnets. And there's like, I guess more than one part of that field. I'm just talking about the immediate part that's right next to the coil itself. It actually is bumped out quite a ways. And when the force, when two forces interact, instead it's like, you know, the coils are right on top of the rotor. I found out that you know, yeah, you get some speed real fast, but it doesn't last. And it actually kind of gets in your way. It got in my way anyway. Having that, I guess the permeability of the copper slow down the rotor. Let's see what we have to move in 2 away, 3 away, 14, 1500. Now let's move them back in. We'll do them in the same order. $14, yeah, it's going down now. See, that's the thing. Definitely a thing. Alright, we'll back them out. I must have had a cross wire because my SSG output is on now. It wasn't on before. Alright, saw it flicker, one of the two. I gotta check this. I don't know, it doesn't seem like anything's like flashing or nothing's sticking out in my mind here. Maybe just a flicker like that. $17, $18. And with the coils all bunched in together, you don't even get past 1200. So it's like almost at 2000 here. See that vibration in the shaft though, once it gets to 2000, man, it's like any imperfection is going to be seen. For sure, man. I mean, so I wonder what our next connection should be. How about we disconnect these 3 coils and just run the interior, this one right here. One with the trigger on it. The only thing about the spreads is that they gotta be 90 degrees in order for, well, you can try some offset stuff, but at least the drive coil's gotta be at 90 degrees. Alright. I might have to turn down the power too because this is going to be a substantially higher amp draw. Don't want to fry anything. Let's see here. And leave everything else hooked up for easy access. Alright. I think this one's actually going to get us going the fastest, the quickest, but it's going to be off balance on the rotor more so than it is without the other coils. Because it's all pushing right here. If there's any like size differential in the bearing or anything like that, this is going to be the most unbalanced you can run. What I mean is if the shaft goes through the bearing, if it bounces around in there, you know, any pushing on that is going to cause a vibration in the shaft. All right, so we'll start at 3.06. Give it the air gap again. Once it gets going a little bit, the magnetic field kind of is pushed outwards by the force. I think it's centrifugal force. I'm not sure which force it is, but it reaches farther when it's spinning. So you can back it out. And you can't start it way far away, but you can back it out as it speeds up. I think that's too far. No, it's going up. 500. $600. And this is just 3 volts in. So I was thinking I was at 9 for a second, but this is only 3 volts in. We're pulling like we were at 9 with everything hooked up though. And that's like 4 times the amount of 16 gauge that's in there right now. 1,000, we're coming up on 1,000. Okay, well, I don't know. I think it's a little weak. I think just the one coil is a little not strong. So I got an idea. We're going to hook up the 180 coil parallel to the SSG. So I'm just going to hook it to the SSG where this one's hooked up at. First we'll back it out and then we'll see what's up. $1,070. 1,072. I think we're done. Seems a little odd that it would only be going up this much, but I guess, yeah, it's 1,000, we'll say. Where's my notebook? Here it is. There it is. Okay, we're going to mark coils. Magnets. And then we're going to have wire, wire, 2 wires. Yeah, alright. Then we're going to have our SSG box. And that moves very smoothly when there's no power. It's the maglev works. It's just too high on the shaft. Um, and if I wanted to put it back, and when I put it on this bearing right here, this is what I usually run it on, just resting on this. It's really loud. Uh, Somebody, you know, made a correlation to it and the warp drive in the '60s series of Star Trek. All right, so 26, 16, 16, 16, and 16. One, two, three, four. So 16, 1, 1000 RPMs at 3 volts. Okay, let's hook up the next coil parallel. We'll go 16, 1, 3, parallel. We'll run it at 3 volts as well. So positive. So easy to hook up, man. It's so easy. You just gotta untangle your wires every once in a while. Because if you switch a lot, you'll know. You'll know what I mean. If you switch your stuff around, you will have to untangle your wires every once in a while. If we can make a contraption that will make it so that doesn't happen with all the flip-flopping that I do, I'll pay money for that. Anyway, we got the 2 parallel hooked up. We got 180 degrees hooked up now. We got coil 1 and coil 3. I'm going to turn the power on now. Oh, I never went anywhere. Oh, I hope you didn't go anywhere either. Something's not right here. Uh-oh. I might have got the wires backwards. Yeah. Yeah, you did. So those 2 coils were like totally equally opposing each other. So that's a good thing. That happened. Because they were set up in reverse and it stopped instantly, so that's good. Oh, please tell me I didn't blow it. Oh man. All right, something's not working out right here. Okay. Black the negative. Red. My hand is the negative. What the hell did I do? Good God. I think this will right. This will be right. Turn it on from over here. Oh, I never turned it off. Huh. That's not good. All right, we're going to start up close. I swear it's not me. It's an incompatibility with me, and well, it is me. It's definitely me. But I'd say it's more of an incompatibility. With, when we talk about a battery, we're like plus minus. That's how you say it. It's not how it goes out of the battery. It always comes out the minus side and into the positive side. But that's not how you say it. Okay, so that's not how you should write it. Maybe we say it wrong. Maybe, when we say battery at plus minus, what we mean to say is minus plus, but that doesn't sound right. I don't know. It just, that very thing right there gets in my way all the time when I'm working with other people. It's like I fumble on that. I'm not blaming anybody. I'm just saying that's hard for me. Plus minus, I'm looking to hook up the plus first, but it's not the way it works. $900. Gonna let it run for just a little bit longer, and we're gonna back these coils out. I'll get it one of these days. I mean, I guess I get it already, but I screwed that one up. I screwed the pooch with that one. Hooked it up all kinds of backwards and sideways and not right. Alright, so we had a significant drop in speed. Now we're picking it up again. Pulled it too far back. Hmm. 900 again. So it looks like we're gonna get 1,000. $950. I'm gonna move it in a little bit, both coils. Next, we're going to hook them up in series. So they're going to be hooked to each other instead of hooked both to the SG. We'll give it 1,000. Gotta get my stopwatch out. I want to give it 101 or 1. I want to give it 1,100. Maybe 1,050. All right. So coils 1 and 3 parallel are 150 RPMs, 3 volts. We'll say 0.2 to 0.3 amps. So 200 to 300 milliamps is going to be our standard, I'm pretty sure, for this whole thing. Except for maybe when we do all in series. Try and clean up a little bit as I go. It's kind of hard to get these out of the mess sometimes, though. So you kind of postpone it, and you postpone it until you just got to tear it all down. All right, so now they're in series. Let's see what we get. Oh yeah, that sounds different. Even sounds different. We're pulling, so far we're pulling half the amps that we were. All right, so doesn't sound like it's kicking though. Maybe we should move the coils. I don't know. Let's see. 750. 760. It is moving. I'm gonna leave it for a second. So all these tests are being done under watt. All right, let me take another tech reading here. 930. Sweet. It doesn't even sound like it's speeding up at all. And holy cow, man, we're at like 0.3, like a quarter watt right now, a little above that. Okay, so we got two options on paths to go next. We can either leave the series the way it is and hook up another coil parallel to that series, or we can hook up all the coils parallel, all three coils, or we can, what else can we do? I think just those two things right now, maybe one more thing. Anyway, we're incorporating a third coil in, and we need to figure out exactly what we're going to do next because we have options. $9.56. Wow. Let's see if we back this out a little bit. That amp draw goes down even more. $1,002. At 3 volts, man, but I think that was a little odd, you know, that was longer than the other two, so I don't know if we can really count that. We'll give it 1,000. We should be marking the time down too, though. That's the thing that's bugging me. I don't have a stopwatch. Beautiful, though. The amp reading, so cool. That's like a quarter watt. Sweet. Okay. I guess we'll hook it up. We'll hook it up parallel first with the series, and then we'll hook it up all parallel, and then we'll hook it up all in series. That's the other one. The one that should have been in my head first. You know? All right, so this is the negative. And this is the positive. Man, that 16 gauge is nice and stiff. Now the amp draw should go up slightly. So now I got these two in series, and this one parallel to those two. And that amp draws crazy low. That's awesome. It's only 3 volts. $500? Are we going down though? That's what I'm wondering. Yes. That magnetic field is not strong enough at the moment. Huh. Looks like the parallel coil is not going to work. That's weird. It's okay though. Something, just looking to see if anything's like touching, and it's not, so. All right. We're going to take this. We're going to clip it to this one. A little stiff. And then we're going to take this blue one. We're going to pull it over here and clip it to this one. Boom. All right, I bet that's going to run nice and smooth. Ha, didn't run at all. Here we go. So yeah, our amp draws down to like 50 millivolts. It's awesome. So this is all in series. One, two, and three in series. I'm thinking with all the copper that we're adding, we should probably turn the voltage up, but we're not going to prejudice. Wow, it's going up on its own. Usually that's at 05. Where'd I put that? Huh. Doesn't look like I need it, but there it is. Nice. Almost 400. What? Or 500? So I think we're gonna go 555 at 3 volts for this. No, we're gonna go 475. But you just turn it up a little bit with all this copper, man, it's gonna go fast. Okay, let's hook up the next coil. We're just going to do a series connection. We'll worry about parallel later. I'll bust out my homemade switch and we'll check that out. And we'll get a tach meter and an oscilloscope reading and all that too. It's a little different on the homemade switch. Okay. All right. Yes. Perfect. But of course, I've had this set up already, so I know the clips are right. All right. Now, plug the negative back in. Sometimes this bench power supply doesn't, if the wheel's moving, it won't function right away. There we go. It's going too fast. It'll cease, like it won't work. So now we're all 4 in series. 1, 2, 3, 4, 16 gauge in series. The amp draw is sickly low, man. It's like in cardiac arrest. However, with all those coils, 3 volts is not getting us 1,000 anymore. Maybe 350 with this. See, in order to make it go faster, which it will more efficiently, you have to turn up the voltage a little bit. And that would ruin the experiment. That's one of our constants. But now we can do it all over again, and we can make the voltage higher if you want. What is it that I wanted to do? I had a really cool thing I wanted to try. 12 volts. Wow. And the copper's close. We're at 1600, 1700. Nope, 1695, 1700. I bet if I back these coils, look at that, man. We're not even at 200 milliamps. That's great. That's freaking cool. That's like 1.2 watts right there. $17.20. At 12. That was a phenomenal 12 reading. Usually it's higher than that. And it's close. Got a nice output on the light there. It's like brighter than it would be if I plugged it into the ceiling. $1,300. I'm going to have to lower the voltage. 1600. Nine volts. Let's try that. See the rate of increase increases. Yeah. Yeah, that's what I'm talking about. 9 volts in. There's our money. I'm not an inventor, wise ass. That's how you say your name, right? Wow, those are all just the wrong questions, bro. Hey, what's up, man? How we doing? Mm. And I'm sorry to say, all this stuff has been done before. All of it, like all the measurements have already been taken. I'm just having fun, man. That's what I'm doing. Somebody wants to get in the way of that, there's something wrong with them. And it's true. It's so true. Especially if time travel exists. All this stuff has been done before. And I may have done it. Alright. So what I was zooming in on this coil here for, this blue coil, is my motionless electric generator. We're going to get a reading on how much that blue coil is generating off the coil below it. It's contactless, so I can like lift this coil up. It's not connected in any way to the drive of this thing. So all the energy is definitely not coming from any direct connection. We're getting it off the EMF field. And here we go. Let's turn this on just so we can get the reading. We'll go 9 volts in. Let me know when you can hear something. You hear that? Well, this actually is a rod that goes all the way through both coils. That's right, Brian. I'm going to drop it all the way down. You get this nice resonant hum. And there's the light showing that it's working. And we're getting 84 freaking AC volts. 84.6 off of this coil right now. That's ridiculous, man. That's awesome. It's just 11,000 turns of 32, man. It's a tiny coil per generation. Wow, I'm so excited. But we're at 9.2 volts in, 2 amps. We got our light. Well, let me explain the drive coil. We got the 18 gauge drive. We got the 20 gauge that's lighting the light. And we got a 32 gauge strand that's hooked to this coil. But it's not directly hooked to the drive. It's part of a trifilar coil. So when it's on, we get a boost. And that's okay. Nobody said we couldn't boost this thing. You know what I'm saying? So that 32 gauge strand is tied in series to this strand, and they're both getting the benefits of the generation of the 18 gauge drive. I just think that the 18 gauge drive, I don't know, it's 1-to-1 with the 32 gauge pickup. The only problem with that is I don't think we're getting many amps with this, and we're pulling 2 just to get it to 84. Oh, you want me to put, oh, a magnet. All right, Brian, I got you. Let me get a good magnet. Let me get a nice magnet. I'll be right back. It'll be perfect for this. All right, so we got our neodymium cylinder magnet M52. The voltage went down about 5 volts. All right, I'm gonna flip it. That one was less detrimental. It's about 83, 84. Here, let me tilt this so you guys can see what I'm looking at. Good, you can see it. All right. Take it off. It goes up to 85. Flip it, put it on. So that's 80. You lose about 5 there. And then you flip it over the other way. And you lose about 3, no, actually about 1.2 right there. So I would say we're going to test and see what this is right here, north or south. Okay, so I believe it's a north orientated as is. So this is north going down. Very cool, man. And this is a powerful, powerful magnet. Let's see how fast it's going. Heck yeah. This, I believe, is a much more stable way to generate electricity. What you call it? Solid state way. Either a Tesla coil or, like I'm going to say it, because it's a motionless electric generator like this, or anything solid state that doesn't have to move is going to generate more stably. It's going to draw more stably. Yeah, I don't know why. Yeah, we're good. I just I don't get it. I need to ask a question. It's like, why do people think they can be mean and not have people be mean to them? Why does it break down like that? And that's just for people who are mean, I mean, why do they think they can just be mean all the time and nobody's going to ever be mean to them? And this is where, the people that apply. I might be one of those people. I don't know, it perplexes me. I don't smoke enough weed for it to go in one ear and out the other. I don't. let's see here. I want to hook this meter up because it's heavier than this one. This one's really light, okay? And this one has basic operations, basic tools. This one is heavier, has an oscilloscope, and I do believe that it can read amps better than this one can. So I'm gonna get that hooked up. Just need 2 clips. Oh, I have a feeling you're so wrong about that. I don't know, no, I can't understand it. Hello, hello, how we doing? I was also thinking about maybe like putting that cylinder magnet in the hole instead of the metal rod. See what would happen. But I think if we're gonna do that, we should look at what it's made out of instead of what its properties are. Because I think it's gonna be more dependent on what it's made out of as to what effect it's gonna have. So neodymium, nickel, forget what the other coating is. See, whether you care or not is irrelevant. That's the only thing that really doesn't matter, whether you care. Because it's all about the action, not the reaction. Being mean, I mean, if you're looking for a reaction and being mean, that's something totally different. And you need to seek mental attention. Because that's just vogue. Being mean is something totally different, man. A lot of people can't help it. They really can't. When you can't help it and you're doing it on purpose, that's bad and you need to be punished. I'm not one to say other than, you know, yeah, that's wrong. And quite literally it should be like, I don't know, man, those people breed monsters. They really do. And a monster can be an innocent young child. You just don't know. Push all the buttons and you'll see what happens. Like I said, you know, I have personal experience with being, you know, a certain way and then having things happen to me and being another way when you come out on the other side. It's PTSD, it's trauma. Anybody that wishes to contribute to the, I guess the new trend on TikTok is fuckery, you can blow me. Try biting it, you'll break your teeth. No kids allowed. No kids allowed. Not today. It even says it. I don't like to argue. I'm not good at arguing. I hate arguing. Arguing makes my head hurt. I'm not quick-witted. I'm pretty fucking smart, but I'm not quick-witted. I don't like to just, no. That's a different way of being smart, and I don't necessarily appreciate it at all, because it really doesn't add up to much. So I'm gonna just take a second here. Half an amp. We're generating half an amp. So, and my message is real, but it gets lost in my anger. I have a message here that's like important. Because that little kid you're picking on is probably worth 10 of you picking on him. Seriously. At least 10. And I know, man, I've been on both sides of that coin. Being the one who's worthless and being the one who's, not worthless. And see, I am mean. I'll use terminology like worthless. I use that shit. Because I think, honestly, it's because I think the stuff that I do just a lot of the times doesn't have much value. It's fun for me, but it's not cheap. It's pretty expensive. I'm raising 2 kids. I gotta back off. I gotta have fun, but I gotta back off. Gotta be a happy medium somewhere. Yeah, I hear you talking about my man. Oh. Yeah, when you're a single dad, it's hard to know what to do all the time. And sometimes you don't want to do what you got to do all the time because you're always doing it. There's most of the time it's a great experience, but I mean, there are a lot of the times when you just want to be left alone to play with your toys. But, and then there's just all that stuff, man. You got to keep it on the wraps, too. You can't be exposing your kids to your woes. They don't need to know anything about that. And I've had trouble with that. I have gone against what I believe has to happen as a parent. Everything's got to, especially at this age for them, everything's got to appear like it's okay. Or it could be like not good for them. And everything's not okay. So it's really hard for you. You got to lie to them sometimes. You got to be like, yeah, we're good. But, I'll never bow. Unless there's a good thing to bow to. I mean, it's strange because my will, I can survive on my own. But I search just all the time for something worthy for me to take a knee to. All the time, man. And yes, it is important. There is a hierarchy and you are in the middle, not the top. You're not at the bottom. I don't think any human being is at the bottom. Although a lot of people want to try and go that way, it's like that's not where you are. You're in the middle, and you got to live to those standards, or you're gonna feel it. You're gonna feel the pain, man. You're gonna feel the frustration of not living up to those standards. Like if you choose to not to do the dishes one day, then the next day you got twice as many dishes. And the same thing, man. You choose to use paper plates. Now you got to change that trash bag before you go to bed. And it's cool. A lot of people are good with doing that. If you making these things is what people do so that they can live in that paradigm. You know, they buy paper plates knowing that they're going to have to change that trash bag, and they're cool with that. So they're living in that paradigm. But I don't know. See, that's what I'm struggling with. I don't have a paradigm really. Don't have a real reason. But I think I should start practicing. That's all you can ever do is practice. Guy out there said he was a samurai master, right? Cut his thumb off, sheathing his sword. That's awesome. I don't think you can self-proclaim yourself an expert anything. I think I am a builder. You know, I put all this together in my head. I'm not an engineer, so I mean, use precise measurements. I used ruler measurements. And yeah. Sorry, I haven't looked back in a while. The ego feeding response. Right, no, that's so true. But hey, um, if you can hear that when somebody's typing it, because it's really an accent on your words. Then yeah, I can do the same thing. I can like look at it and I can know, and it. I don't think it matters good or bad. I think if you're cool, if we're cool. You can step on my shoulders to get up. If we're not, I'm gonna pull you down. Yeah. Most of the people I let walk not all over me, but up me so that they can, you know, get higher. A lot of people that are involved are already up there, so I mean they don't need as many shouts out as people that do. But yeah, I don't know. And the people that think I gotta come up with the latest tech to have a channel, I don't know what to tell you. Because I mean, I'm gonna keep coming at you like that until you admit that you're just being a dick, and that's when it's gonna start. So we got 87 volts and a half an amp coming out of this coil right here. That is phenomenal. Actually, it's the 32 gauge in the lower coil, and this coil combined, which is giving that reading, and I thought the amps would be skyrocketing because of that second connection, and I was right. That's like 300 more than I would normally get, almost 400 more. Yeah, I wish that I could have like a moderator, like that could take care of the channel while I'm working, that knows about what's going on and can discuss it. But oh, hey Robert, no, I'm just talking to myself about needing a moderator, and it's true. So, but you know, I had moderators before, and I don't know. I feel like their agendas kind of got in between them and moderating, and I guess because of, like I said, the fact that I have an attitude sometimes, I guess my views dropped, and then my moderators got attitudes. So I don't know about that anymore. I mean, I need one, but it's got to be cool. That's cool, Robert. Heck yeah. Me, I have a learning disability, so I'm just trying to have fun, as much fun as I can. Uh, I mean, it took me 2.5 years to learn how to make all this stuff. But I learned it off of YouTube, you know, and some of the answers that I was getting from my questions differed, depending on who I was talking to. So that didn't help. Oh, that is awesome. Wow, 1900. $2,000. Gotta cut that back. See, when it hits 2,000, the shaft shakes violently. I think it's because of how high it is on the shaft itself. See, it's really buoyant though. So it'll bounce up and down. All right, over here, this is running at a frequency of 369 with 9.5 volts in and 0.7 amps. 50% duty cycle. Running on a PWM. I want to show you something pretty neat. I think it's pretty neat. I'm going to turn this all the way down to 1 hertz. Now you can't really see it in this one, but this core is like violently shaking. That's neat. All right. Like on that spinning still, like pretty awesome. Let's check the speed. Oh, 11. Not so good. Now I haven't hooked up the propagation connections. For which one? Well, this one is truly just an experimental apparatus. So far, we've done experiments at 3 volts on 5 different connections possible with these coils. If this is 1, 2, 3, 4, we did 1 at 3 volts for 1,000 RPMs. We did 1 and 3 in parallel for 1,050 RPMs at 3 volts. And this is like, we're going to say 45-second test. So the time and the voltage are constant, or they should have been constant. But the more coils that we added for 3 volts, the more the RPMs went down, but the more balanced the rotor would become. Now if I could put a little bit of weight here on the top to force it down a little bit on the shaft, it wouldn't rock as much if it was a little lower. I wouldn't necessarily, yeah, that would be it. And that would equivalent to efficiency data. I'm like which spread of coil, which one works the best at 3 volts for speed. And I found that the single coil works the best at 3 volts. And the 180 parallel to the SG works about the same as the single coil. All right. And then this one, we're trying to get the data so that we can turn it into a propagator. So we're trying to have, more volts generated than we need to make the next one pop. And then I'm thinking if I can get the third one to work, third section, which this is a section right here. So if we hook 3 sections together and then wrap it back into itself, will it propagate at all? And I keep on saying it'll go up until it reaches the capacity of the coil itself, and then it'll stop. But I got a counter rotating pulse motor that I'm working on. It's a toroidal counter rotator. And it's cool. I'm really proud of this right here. It's like this ring. See these tubes? See the holes in the side where the tubes reside? All those had to be the exact right measurements to put bearings on this. So it'll roll now. I wish it was flat though. That's what I'm saying. If it was flat, it wouldn't be bumpy like that. But with the bearings, which were 1/16 of an inch on each side, so 1/8 of a total inch, but we're only dealing with the 1/16 on the inside, so that 1/16 of an inch has to be around, you know what I'm saying, around the whole thing, so that the bearings can go on the tubes on the bottom, and it fits well enough for it to spin at least that good. There's not really any friction except for the bumps on this thing. And it's 64 sided, it's as circle as a circle could be on the Tinkercad. So maybe I just need a new AutoCAD software. And then the magnet in the middle That's what's going to make it spin. That's pretty freaking stable. I had to do a lot of things with the thing in the middle to make it even and spin right. So, I mean, it is bent, the pole is bent, but the stabilizers don't shake anymore. Because it's a perfect fit for the toroidal. So all the magnets and batteries and stuff are going to go on the inside of this. And it should, spin like a motor when I turn it on. Heck yeah, Robert. They're really awesome. They can be a pain in the butt too, so get a sturdy one. Don't get a one where you got I like to call them choke points. I'll show you what I'm talking about. I got another printer over here that totally, like, it got chafed to the point where it just wouldn't function anymore. And they even put a little cover on it because they know that it was one of those points. You see, you lift the cover off and there's all those exposed wires right there. Yeah, man, you don't want one of these. You do not want a printer with something like this, even if it has a cover like this. The reason the cover was even made was because they know that that was a problem. So what you really want is something like this. You can't really see it though. Something like that. So it's all protected and it's not going to chafe. So the thing that's going to bang against the side is going to be this casing. Perfect. I recommend running, for most prints, 230C instead of 220. That I also recommend. One, I believe it adheres to the bed better on its initial run, and it's a lot smoother with pretty much all filaments. I think PETG is even higher than 230, so PETG might have a different setting. I'm just talking PLA, all varieties of PLA. And I'm not saying that's what an expert would say. I'm saying that's what I've figured out trying to print something 100 times and have it fail on the first part just because the filament isn't like wet enough, melted enough, the right consistency to print with. But like if you're an expert, you go into the settings, you got all these specific settings that you use and stuff. But I use the default templates for a 230. Usually generic PLA is any generic is 230 right off the bat. Yeah, that was a terrible, it was terribly costly. I didn't go through a whole spool of filament, but I did it like 4 or 5 times just to figure that I needed to heat it up a little bit more. You know, it is, yeah. Anything to help. It can get frustrating. It can be frustrating. Oh, you want to keep your plate as clean as possible. Now this is the power right here, but I like to roll with this other rotor too sometimes. There's 3 bearings going through the middle. Now this is a 9 magnet rotor, so I don't know if Alright, so in order to make this work, it's going to look a little weird. Magnet, no magnet. Come on, man. There's too much glue on the table. It makes moving stuff around really difficult. Alright, so there we go. I can't really see where the magnets are. I was trying to count, but the tape is covering all that stuff up pretty good. I got another idea. That's an awesome rotor. Very, very balanced. Mm. Mm. Got this 12 magnet rotor. It's 14 inches in diameter. Now this thing is cool. I love this thing. But let's flip it over. That's way high on the shaft though. Huh. Okay. We'll lower that a little bit. Now that'll sit right on the table pretty much. Sit right on the table. Yeah, that'll be a lot more balanced. I gotta see what's knocking. I love this rotor. It's so peaceful. So peaceful. I knocked the tinfoil off of it though. Why did I choose this rotor? Two reasons. One, it's nice and peaceful, and then two, it'll line up at 190 or 90 degrees. And since only one of these coils has a trigger coil, they all have to line up. Alright, hello everybody, what's up? This is Papa Bale, and we're looking at Pulse Motor Mayhem here. We got our bifilar coil at the head, that's our main drive coil, and then these are all single file 16 gauge coils that I've attached in one way or another to the drive coil. We're currently using about a half a watt, between 0.9 and 0.5 of a watt. This is currently the only coil that's hooked up. It's pushing this wheel. See, this is not well balanced wheel at all. It's got 2 ceramic bearings though. It's got that going for it. There we go. Then I got the motionless electrical generator over here on the corner of the table. Yeah, it gets a little wobbly. So I was like, what type of transformer would this qualify as? Using ratio. Now that we got some kind of amp reading, I'm not sure if it's right, but it's a reading. DC amps. 95 volts of AC. We're getting DC amps. AC amps is 270. So AC reading and AC reading. Let's see what we get. Looks like about 1.8 watts. Close to that. Say 2 watts. And that's right about what's coming out, a little bit more than 2 watts. So I'd say that's a 10 to 1. Or it's a 1 to 1. My bad. It's going to be a 1 to 1 for the most part. Voltage is 10, almost 10 to 1. It's 95 volts. We're putting in 10.2. So it's a little shy where I would want it to be voltage wise. And then it's above where I want it to be amp wise. Funny enough. We're putting in 1.9 amps and then 10 to 1 or 1 to 1. That's about right. I mean, 1 to 10, basically. It's not. It's close. All right, let's hook up the propagator thing. And then I'm gonna go get something to eat. But basically, what that is, and first, there's several ways I like to try to hook this up. We're gonna do a parallel connection first. We're going to use the rectifier diodes, just 1,000 volt 3 amp diodes. All right, so we need the positive end. All right, so now we got the beginning of this coil going into the beginning of the drive coil. We're going to do the same with the negative end. But this will be one of two things: to give power to the coil and to totally separate it from each other. So it's not going in a continuous loop, it's being cut and distributed this way. All right, so all right, let's turn it on. So this is a one section propagator that I've now turned back into itself. '89. I don't know. So I don't see much of a difference there. Now maybe, just maybe, if we take one of these diodes and flip it, so now the coils are in series, and it also looks like they're going to be shorted. All right, so that way we get way less. Wow, that's interesting. Looks like we got about half of what we were supposed to get. So that needs to be that way. So if there was any question of whether or not it was affecting at all, I would say, yeah, that's a definite yes. That affected it in a negative way. All right, so now I'm going to flop the other one. probably get the same difference. So all these do is one's clipped to the generator and the other one's clipped to the drive, the diode in between each connection. Yeah. So it's definitely for better as a parallel connection, with the north and the south end of the coil being directed back into the north and south end of the drive. But that's how we had it hooked up first for the, not usually how it goes. So the question is, does this hookup right here do anything at all? Does it do anything? So what we're going to do is we're going to unhook it. No, it didn't really do much. We don't have to unhook the other one because we will anyway. Nope. Okay. So it's a connection that doesn't really do much. At least not to itself. Which makes me think that if we had another section and then connected it back to itself, it would do the same thing. But this alone as a generator, I think is awesome. We're generating about 100 volts. We're 10 volts in. That to me is a 10 plus win. But we're only at 26. And we're at 2 over here. So that's a 10 up on one side, 10 down on the other. But I'd say that's pretty good math. To have it be like that, have it be any kind of ratio, just winging it is, I don't know, it's more than just luck to have it happen as many times as it's happened with me. But I've failed a lot too. And I haven't replicated a damn thing. I can't read schematic. I mean, I consider myself pretty freaking logical and I can't read schematic. Not for the life of me. So, yeah, this is this guy's thing. No, it's not. No, it isn't. I mean, if I read about it at all anywhere, you could blame me for building somebody else's thing, but I don't even read. I don't read. Ladies and gentlemen, I don't, not for pleasure, and I've done it as little as possible as I can for work. It makes my head hurt, and I don't know. I wish I could have found more pleasure in reading. Like that toroidal behind me, those measurements are sick, man. I had to print 3 of the toroids to get it right, but I got it. It's 7 3/4, and that would leave a total 1/8 around the circumference for the bearings. All right, let's try this now. We're gonna hook up the other 3 coils. Oh wow, did you hear that? You hear that? That's sick, man. This thing is off. Woo-hoo. 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 So there's two types of transportation experts that you can get to honk their horn by going like this. Can you tell me which two they are? Because both of them have a pull string to honk their horn. One is a semi-truck. Got lots of semi-owners to honk their horns. That was pretty cool. And the other is a locomotive. Yes, sir, Brian. That's the one. That's the two, actually. The two that are most pronounced in my mind. Trains and 18-wheelers. So that's hitting pretty good. We're going to see if we can make it shake a little less. Going at a faster speed. And that amp draw is like seriously sickly low. Man, I wish it was more balanced. It's such a beautiful wheel. But I don't know, the scheme I had for the Neos was a little off. They're 20 inches in their thickness. I mean 20 millimeters in their thickness. And the holes that they go in are only 10 millimeters. So they're designed to stick out halfway, which in my opinion made them stronger. But yeah, it was a bad choice in the design. I love that, man. It's off, and listen to it. Yeah. So what I'm gonna have to do here is I'm gonna have to remake the drive, or because I want everything to be the same. I want the drives to be the same. I want this to be in another 11,000 turns of 32. That's what I want for this thing. And I want them not to be so thick, like long. I made a drive for this, but the coils are too long, and what comes out of here isn't that great. I think you need like maybe high voltage to make that work. Mm-hmm. Yeah. So I think I'm going to maybe make some 45-degree coils for this. Have them be like generator coils. But I'm gonna do this first. And they could probably be interchangeable coils. So I'm gonna make it, it's gonna be 11,000 turns like this. It's gonna be one like this for each 45 degrees. But I mean, with those 4 coils hooked up, we are not even drawing 50, like 50 is our average for draw. 50 milliamps. I tried hooking up the 18,000 turn coil, this one, and it didn't generate anything really. So I'm thinking that they gotta be flat, and they gotta be close. Maybe not 100% flat, but. Well, I also had another idea, like I'd make it a third this thickness, blue magnet thickness, which is like that thick. Make 3 of them. But then I'm like, that's not logical because if you just make one the size that 3 would be, you got that much less plastic in your build, and you're going to get more energy. Because it is totally about how much of that copper is in the field. 100%. For what we're doing. I mean, we're collecting EMF, so we got to be in the field. But I was thrilled that we were getting almost 100 volts off of that coil. Literally freaking thrilled. But let's check the difference between a core and no core. And then of course we can mess with the hertz. Hertz are at 369 right now. Take the core out, we're doing, wow, it's hot. Holy smoke, the core is hot. We're doing about half the volts, same amount of amps though. Oh no, that's DC amps. Amps got cut in half too. Like literally in half. So the core is a necessity. See, it can run forever on 3 volts. You know what? That's 3 volts. Let's see if we can go lower. So yeah, we can cut that in half too. 1.3. Is it gonna be enough though for it to be on? Doesn't look like it. .43 volts and a handful of amps every now and then. Hmm. I want to put this thing in here. Oh, that's a really tight fit, but yeah, I don't know. I don't want to put it all the way in there. We'll never get it out. I got an idea. Another brilliant idea, I hope. Um, right now we're using that 20 gauge strand for the light bulb, and we can continue to do that, but we're going to hook it up. You know what? It's a good idea, but I think I'm going to do it later. What do you guys think? I'm going to hook the 20 gauge into the one with this coil, and I think our amps will be even better. Oh no, we're going to leave that the way it is. hopefully we'll get the light lit too. All right, let's see if I got it right. Shouldn't have been too hard. So not too much greater, maybe even a little less. That's all right. We still got, I think it's still good numbers. I mean, 90 and quarter watt or quarter amp. Let's see, what is that? 22 and a half. And then times together, it's going to be about 2.4, 2.3, 2.2.25. I don't know. It's going to be below 3. That's for sure. I think. So I'll be playing around with connections on this thing, trying to get a max output, and then I'm going to start, I don't know, we might try and use a cap of some kind in between each section. We'll definitely, yeah, probably use a cap. Going to use some diodes, probably Schottky diode. Or we could use the rectifier diodes, which are a little bit more voltage and a lot less amps. I love how this little thing is just clipping away. Bingo. Why is it doing that? Why is it making it sound like it's on when it's off? Well, one reason might be this connection I have right here. This takes the trigger strand and plugs it right into the positive of the drive coil. But I'd say that is producing quite a bit of heat running that. Oh yeah, that's hot. This iron is like softer than it was when I put it in there. Come on, man, you look like a guy that might know what this is. It's a pulse motor. That much is. So it's a pulse motor. Currently, it's not generating anything. These are all single file drive coils. Was pondering putting generator coils at 45 degrees. That might look nice. This is a motionless electrical generator, and I have it set up currently to a PWM. So at 10 volts in, 2 amps, we're currently making almost 193.5 and 270 milliamps are being generated. I'd say that's about a 1-to-1. If you do all the math, you do the amp math, you got times 2, times 10 down pretty much. It's a little bit more amps than times 10, or divided by 10 I should say, because you're taking 2, you're generating 0.2, 10. Okay, then we're putting 10.5 in and we're almost getting 100 out, so that's 10. But it equals out to be 0 when you do both of those maths, because, you know, well, not 0, we can't say that. I'll write this down and I will do this on my calculator. And then the input is 10 and 2.0. And then we'll do a wattage equivalent. This is a 14-inch rotor with 12 neodymium magnets in it. Congo magnets, man, these are big magnets. We're currently putting 3.05 volts in, roughly around 150 milliamps maximum. It's fluctuating on the draw. I believe it's because of the imbalance in the rotor that it's being so fluctuating. But the amp draw is really low. This is 16 gauge wire with a 26 gauge trigger and 1 coil. So this is the only coil that triggers, and so the other ones have to be lined up on the magnet. That's the drawback of having a single trigger. If it triggers offset without its own trigger, nothing's going to happen. And when I say offset, I mean in between. I don't mean slightly offset for speed boost. That's not what I'm talking about. Because, let's see. We're going to go slightly offset like that. See if we can get a speed boost. Sounded like it was going faster. But that's not what I mean. I mean, you're putting it in no man's land, and that is not where you want it to be. but having 4 of these coils hit at the same time it's really quite powerful. This is a 14-inch rotor. It is running on ceramic bearings. It'll never get going really fast, and if it does, it'll shake all over the place. I made this a year and a half ago with my first 3D printer. So it is 3D printed. It's beveled. I paint my rotors every now and then. But I say not bad for 3 volts. And it's virtually like 3 volts. The milliamp draw is next to nothing. So there you go, like 200 milliamps now at 9 volts. I don't think it's going to make more than it uses. Not this thing. We are keeping an eye on all that crap, though. We like to measure that stuff just because it is something you can measure. And the mag right here, yeah, we're looking to get as much power out of this as we can because we're going to propagate it. We're going to send it to a next assembly that looks just like this, and we're going to try and do it with just the initial power. See how far we can get down the line. Going through segments as such. Oh my God, dude, the freaking output is on right now and the power is freaking off. That's crazy good. That's freaking awesome. That is too righteous, man. I didn't think that could happen, but I guess it's out of the induction, the magnetic induction and the magnets being so strong. That was awesome. Haha, I'm gonna do it again. I'm gonna do it again. I hope it'll work again. Wow, that was sweet. So you can't see it. That's a shame. All right. The lamp shade with the light sticking out of it is our output. Okay? For the SSG. And as far as I know, all that stuff is run through a transistor. It's still on. The power's off. I'm thinking it's from magnetic induction, but you can't get that much power off of the 16 gauge coil. You're just not going to get that. That's amazing. It's freaking awesome. But it only lasts for a little bit, as you can see. And it's got to be from the magnets. But I think that's pretty freaking cool, man. I've never seen that happen. I mean, when it's on, of course, you get light, but when it's off, am I generating that much voltage that it would turn on? I mean, AC-wise, it's got to be like 77 volts. Yes, man, that's cool. Yes. This coil on the bottom here, it's a tri-filar coil, so it works as a transformer in itself. And then having this be in proximity to its magnetic field, this is a collector for EMF. It's a 32 gauge coil, 11,000 turns. It isn't going to get any more clear than the way I just explained it. But yes, you're absolutely right about the transformers. But it's all about proximity and EMF. The way I have it hooked up, I'm not doing any BEMF hookup at the current time. I might change my mind about that and hook it up so that we use BEMF. Right now it's just a magnetic field that's being picked up, or being utilized, I should say. And then the coils on the wheel here have got to be like they're doing something really cool. But I guess, well, I'm gonna loosely say that the desired result of this is to have 3 sections that feed each other in a loop and have that energy increase to the potential of the coil. Because the coil is like a capacitor. Honestly, it really is. Has capacitance. So we fill the whole unit up to capacity. And you start really small. 3 volts in. That's how we're going to do it. And start at 3 volts, see if we can't make it go up to 100 like it was. It's an SSG. Here, I'll take the camera out here and I'll show you the circuit that's running it. But yeah, the circuit is powering the light because my SLA batteries are crap and they're already broken. But that, my friend, is the circuit from K Energy Store. This is an SSG circuit with a, I think it's a 32320, C2320, something like that. It's a transistor. Yeah, so that's what's turning on the light with combined with the power of the coils and the input power. But what's powering the light is definitely the input power, but when I turn the input power off, the light stays on. So there you got a good power output. All right, now I'm going to turn this off. Power's going off. Power's off. Oh, you can't really see it, but it's on. It is like on, but it's dim. You can see it. My bad. Power's off. And it's got to be the residual power of the magnets generating that, but was definitely on. All right, thank you. Thank you. Yeah. Let's put this back up here. You can still hear it going. I mean, um, it's not enough to make the light go on, but it's enough for it to move itself until it stops. And it might just be the sound of the magnet passing the coils. Maybe that's just a sound that it makes. But it makes it a lot louder when there's power going through it. It's the same noise. See? Same noise. It's pretty awesome, man. I blow myself away every day. And it all might be pretty simple to some people, but there's a whole lot of people out there that it's not simple to. I might be one of those people. I mean, when you get into it really, and you're actually building it, there are so many things that you don't even think about needing until you're actually doing it. And I'm talking when there is no schematic. I'm not talking about replication. That I can do. Measuring shit, I can do that. But actually coming up with the concept, making the measurements on your own, and yes, man, that is true. That it's so fun when you do it that way. And I don't even know why it's like people are against it. I mean, it's so fun and it's so rewarding and satisfying when you get it done and it works. I mean, I made 4 counter-rotating pulse motors. I didn't even know how to make a counter-rotating pulse motor. Granted, for, on the pulse motor's behalf, I think all pulse motors want to counter-rotate by law. They want to. But you have to make it so that your stator can spin. If your stator can't spin, it's not going to counter-rotate. But if your stator can spin, it'll spin the opposite direction. It just does. Reed switches work really good. I made a few with transistors and trigger coils. Hell yeah, man. Creationism. Well, I mean, you know so much that you're not scared at all. Because you know exactly how it's going to turn out, kind of feeling, And even if you get it wrong the first time, you're like, well, that was supposed to happen. It's like, and I like using this toroidal motor as an example of like not knowing what measurement you need to make and making the right one just by eyeballing it. I don't recommend that. Stepper, yeah, I got 2 stepper motors hooked up to my printer right now. So I had to get this toroid in here with having minimal stress on these poles on the outside, okay? Like no stress. So now it'll spin because I put bearings. And granted, these are 1/16 of an inch bearings. And it fits in here perfectly. There's no stress anywhere. The only problem is that the wheel itself is 3D printed, so therefore it has 64 sides, the way I printed it. I want to print one that's totally flat, but I don't know how. You can hear it hit the bump every time it rolls over a side, so it's like, but the bearings fit in there absolutely snug, like below snug. This is like, it's just sitting there. So neat. Anyway, it's not like I started off with a schematic. It's not like I knew how much to make the air gap that needed to be there and everything like that. That all came into play as I built it. And I was okay with that. You know, because I don't have a perfectionism complex. I don't have that. Sometimes I wish I did, but I don't. And I work well without it. You know, so stuff can go wrong. I've had streams where everything went wrong, and I was cool with that. Don't feel bad for me when stuff is going wrong, because that's probably means something's actually going right. The trifilar coil is kind of like a stepper, or you could step up or step down because it's 1-to-1 all the way through. So it's 1-to-1-to-1. That is so sweet. Haha. 1-to-1-to-1. Let me get. Oh wow. Yeah, a long time ago I was messing with 26 gauge and I believe it's 30 gauge. I made a 10 file coil with 8 strands as 26 and 2 strands of 30 gauge wire. I don't know, man. I think I could hook up about 4 strands before they started interacting negatively with each other. So after I built that coil, I realized something. You can't just keep adding copper and things are going to get better. That's not how this works, man. This is very mathematically oriented. So it's like once you pass a certain threshold of copper, then you're going to get a negative return. And granted, you can pump more voltage through it, but I mean, what's the point? Somebody asked me that. I said, why don't we just turn the voltage up? And they're like, well, did you turn the voltage up on all your other experiments? Then what's the point? You know, sometimes this is the greatest thing, man, is when your experimentation does not fit into a category or a confined space, or like I just mentioned, you know, have specifics. Sometimes your experimentation doesn't have to have any specifics. See, like I can just take these 2 clips from this multimeter and hook it up to these 2 wires and do an experiment. Yes, I can. Would I do that? Probably not. Because even I really don't like to waste people's time. I don't. I like to have fun. I like to show people that I'm having fun. I like to show people that it's not hard to do. I encourage and implore people to build their own stuff within safety regulations and limits. This may look like a fire hazard, but it's totally not. I've had stuff catch fire before. It's not a hazard. It happens occasionally, but it does not. What all it was a transistor. When the system was on, the transistor got really hot, and the plastic, incinerated. Nothing burned, just the transistor, and it stank really bad. The stink of burnt transistors in the morning. That is so sensitive, man. That is great. But probably after I close the stream down, I'm going to take all this stuff apart and I'm going to clean up because it's getting to be a mess. It's been a mess for a few days now. So cool. I can't get enough of that. Hey Mike, how's it going? Nice, it's only 1 o'clock. Dang, that's good. Thought it was later. So I want the toroidal to be a 3-phase motor. And I want it to kind of rotate. So that means I get 3 coils to work with. See, so I got this one, it's got the toroid on the bottom. It's centered, it's really centered in there. You can kind of see how centered it is right there. So what the choice is, what do we want to run? I'm just adjusting some magnets here. Alright, that one was a little tricky, but it's good. Now we're going to have a 3 magnet rotor, 120 degrees. Oh, I hope this is right. If it's not right, then we don't have a 3 magnet rotor. And we're good. I've been dying to see how this one will stack up. It's not perfect there, but we'll see what happens. Heck yeah. You can see the pulse in the light is a lot more far apart with the 12, 9, or even the 4. That's got a ceramic bearing in it. 2 ceramic bearings. $700. 850. $9.50. $9.95. So I'm thinking, honestly, that it's going to end up going faster without the maglev. It's going to end up being more stable without that. At least the one that I have, it's not going to work right. I can leave the magnets on the rotors, just not have them be levitated from the magnet on the bottom, so I'll just remove the magnet from the table and use flanges and bearings. Heck yeah. It was really, really close. I couldn't get it any closer than it was, actually. Not without it being like the same magnet. Alright. This one will have a little bit of added weight to it. Let's see if if it's high enough right now. Yes. That's like down on the ground. Yeah, that's going to be awesome. Now I just need to plug that one back in. Oh yeah. Now this should be able to spin for a while. Heck yeah. I wonder if we can get the same reaction on the light, turning it off, as we did with the 12 magnet rotor, and have the light still be on after I turn the power off. $1,700. And now you can hear it again. It's a give and take. 2,000. See, it's a lot sturdier. Oh my God, it's so much sturdier. It's not way up here on the pole. It's down there. $2,200. $2,300. $2,400. $2,450. All right, here we go. Yeah, okay. Wow. Our light is definitely on, and I have to say, it is definitely coming from the magnets making the electricity. This is 16 gauge wire, and that takes a lot of electricity to light up. It's not like a 3-volt thing. A lot of people think this is a 3-volt light bulb that'll light it up. I guarantee you, you're not lighting that bulb with 3 volts. Wow. That is cool. I'm gonna get that up to 3,500. Probably have to put 12 volts in to make it happen, but I'll make it happen. But those coils in like a set, they're awesome. 16 gauge, 4 coil set. I'm thinking it's going to be 300 turns a coil and 1 trigger strand of 26. Beautiful. Because it's like not only are we getting electricity off the 16 gauge, we're getting a lot off the 16 gauge. It doesn't seem like it's right though. I mean, it seems like it should be like 3 volts or less, or something like that. It should be less. Shouldn't light that light up is what I'm saying. So it's obviously getting its power from somewhere else, like a transformer. It's like one of these coils has got to have some kind of capacitance saved up in it. And then of course the inductance from the magnets, but I've never seen it generate like that before, ever. Like ever, and I've been doing this for 3 years pretty much. With 32 gauge, not let alone 16 gauge. That's why it's like making me think right now, because it's 16 gauge. Oh, so cool. See, like right now, there's 14 volts going into that light. It's got to be at least 5.5 volts for it to turn on at all on the SSG circuit. Now that's not far-fetched, it could be 5.5 pretty easily. Now that I think about it. And it's still pretty awesome. $14 volts, 350 milliamps. $1,900. $2,200. $24. Woo. $25. $27. $28. $50. 3,000. Woo! Oh yeah. Yeah. It's probably not supposed to light up through the circuit though when it's off. But it does. So wow, that is so cool. I'm pretty amped up too, man. I'm pretty amped up, but I think I'm gonna have to call it a day for now. It's been really fun. Thank you all for joining me down my hopefully inspirational path of enlightenment. I'm not necessarily trying to do anything myself, but if I inspire somebody to do something, that's great. Even if it's through negative means, it's great. Like if I say, get off your lazy ass and build something, and you do, that's a win for both of us. All right. Thank you very much. Peace out. Have a wonderful night. Bye now.